Why do we want to use recirculating aquaculture technology in the first place? Okay, let's look at some of the reasons. Okay. Well, first, I got to tell you why you ought to be listening to me. Okay, I'm not just an academic. Okay, I, with my own money and my house on the line, we put up £1 million per year indoor recirculating aquaculture production system in upstate New York to produce tilapia. By the way, tilapia is a tropical species, meaning they need like 28 degrees C, 80-degree water, and upstate New York is really, really cold. Okay, so recirculating aquaculture, wow, how could you produce a tropical animal in an upstate cold environment? Well, that's because we recirculate the water. There's just a shot of the outdoors. It was about 40,000 square feet. Looks like a big dairy barn. And then here's an inside shot, round tank technology, etc., etc. Okay. Okay. So here's a little bit about tilapia. That farm was built back in the mid 90s, and we've actually broke ground in 1996 or 97. And my business plans and such were showing like, yeah, okay, well, tilapia is going to become really big, and so this is a disruptive technology, and so yes, invest in me. Okay, well, I couldn't get any investors, hardly. So primarily my brother and myself financed this first farm. Anyway, my predictions, came true. Producing a lot of tilapia. Okay, everybody knows it. But back to the point of this video is, why do we reuse water? Well, the whole bunch of reasons. Okay, but the primary reasons are you reuse water so you're not using this valuable resource, and it's probably the most valuable resource we have. And so using it in a flow through system that uses huge quantities of water is just not sustainable. Okay. The other thing is that the less water you use, the less water you have to treat, in terms of discharge. Okay, as in EPA and any kind of environmental regulation on what you do with this discharge water. The second big reason is in a recirculating system, the water that you put into your tanks has to be water that you yourself are willing to drink, as in there's actually no disease organism being introduced into the water. So when you do that, the less water you need, the more cost effective you're going to be. Also, once you start to recirculate the water, you can control the temperature very closely, which means you can optimize that environment to the animal you're trying to grow. Minimizing water use deals with biosecurity, makes it much easier to control that in terms of keeping disease organisms out. And if you don't need much water, that means you can put your farm where it needs to be located from a market sense. So water reuse systems, there's three basic types. You use serial reuse. It means it goes down, comes back. We don't really talk about those. It still uses a lot of water. We're talking about full recirculation, and this then means you're talking about something zero, which is almost impossible, but 5 to 15 or 20% water exchanges a day. So if you had 100,000 gallons of water in your farm tanks, 100,000 gallons, that means at 15% you'd be throwing away 15,000 gallons a day. If you had 100 gallons, you're throwing away 15 gallons. This is water that's discharged, which has to be replaced. It's not the recycle. Okay. This is a reference point back to the tilapia farm that I showed you earlier. I ran that farm on a hose doing about 20 gallon per minute, and we recirculated like 30 million gallons of water a day. 30 million gallons of water a day recycled. Okay. I used to raise money with investors, and I say, hey, I produce fish with no water. And they go, what? No water? I go, well, a little bit. Okay, well, this slide kind of shows you that, what I mean by none. Okay, so here's what we learned. Big table here. This stuff's all on your yellow book, which you all received and you're supposed to be reading prior to this lecture. Here's my tilapia farm. The ratio is on itself, of course, is 1. Okay, well, what if I was doing a raceway? I would use 2,000 times more water than I would use in my tilapia indoor farm. Ponds, somewhere around 200 to 400 times more water than I would in my RAS, and similar ratios in terms of land use. So it doesn't take much land, and it takes very, very little water. Okay, design. Okay, just a brief one on that. And we're looking here, and here's our fish tank. And what are we talking about? Okay, there's one nice loop here where we've got to remove our solids. We got to biofilter the water from the ammonia and the nitrite. We might have a disinfection loop. We'll probably have a carbon dioxide removal loop. We'll have fine solids. The stuff that goes, this is the material that goes through a window screen. And then, of course, we have to aerate and oxygenate, the water. Okay. So that leads you to, from an engineering standpoint, is that we feed the fish, say a kilogram of feed or a pound of feed, and we have all these production terms. Okay. We produce about 0.03 units of ammonia for every unit of feed. About a half a unit of waste material on a dry basis for every unit we feed. In other words, most of what is fed comes out as waste product. We produce a lot of carbon dioxide. We use a lot of oxygen, and we'll consume something called alkalinity, which is a future video lecture. But these are the engineering numbers we need in order to design the system. Okay, just give you some ideas, on what these systems look like generally. Here's a mixed cell raceway, which we'll talk about also in a future video. We'll produce about, or we'll carry, I say the density is 80 kilograms of fish per cubic meter of water. That's about 0.7 pounds per gallon. We're turning this tank over twice per hour, recycled, center drains, side drains, and micro screens for sticking out solids. Just a general idea of what a footprint might look like in a production farm. You can see here's the building. And the fish tanks, only take a fraction of that footprint. If your growing tanks occupy 25% of your building footprint, you're doing pretty good. Okay, so the building has to be a lot bigger. And another configuration that we designed. This is for sturgeon. These are trying to mimic round tanks, put together in terms of a central collection area for solids removal and then recycling. And here's a shrimp farm that we designed, again with mixed cell raceways. Again, just to give you a sense of what footprints might look like. You always have to be aware that you're going to need an office and a lab and a break room and areas for feed storage and restrooms and hatchery areas and purging areas, etc., etc. Okay. Here's just a quick overview. Here's a mixed cell, what we call a boutique, meaning small production. This is about 20 feet by 60 feet. This will produce probably 20,000 pounds a year of tilapia. Okay, Here's our fingerling. Well, here's our fry stage, goes to a fingerling stage, and then to a grow out stage. Again, make sure you have your lab, office, crew room, restrooms, etc., etc. But this is all put down into about a 50 by 50 area to give you a sense of scale and what kind of size is needed. Okay.